This assessment asks us to draw a reaction coordinate diagram for the lipase catalyzed resolution of the enantiomeric alcohols. Now, I've redrawn this to simplify it on the screen to show what's happening. The R alcohol is being converted to the ester at a faster rate than the S alcohol is being converted to the ester. And so what we end up with is all of the R alcohol as the ester and all of the S alcohol, ideally, left over as the alcohol itself. Note that I said here that the difference is an issue of rate, that it's faster. If we weren't doing this reaction in the presence of an enzyme, both of these would proceed at equal rates, and we would get a mixture of the R ester and the S ester. But that enzyme, by providing a chiral environment, will react more quickly with one over the other. That use of the term quickly is a clue to how we're going to draw a reaction coordinate diagram. Because these two enantiomeric alcohols are enantiomers, they're going to start at the same energy. So we'll use blue here to represent the R alcohol. It's going to start here, and as an ester, it's going to finish here, let's say. Now, the S alcohol should start at an identical spot. We'll put that here. The enantiomeric S ester should finish at the same spot as the R. We'll put that there. So the R and S alcohols here on the left start at the same energy. The R and the S esters finish at the same energy. Well, what's going on? More than likely, this reaction might be multi-step. We're going to assume it's one step. But the fact that the R reacts more quickly must mean it has a lower activation energy. So if we assume one step, we might get a reaction coordinate diagram that looks like that. Starts here, finishes here. And this is the activation energy that's going to determine the rate. How do we draw the same diagram for the S to show that the S reacts slower? We make the activation energy higher, and so it might look something like this. Still starts at the same spot, finishes at the same spot. So in terms of delta G, the equilibrium would be identical. They're two identically stable. The difference is that the lower activation energy process is the faster process. And so our reaction coordinate diagram shows that the activation energy for the R must be lower than the activation for the S. Why might that be? Once again, that comes back to the fact that the lipase, the enzyme, is chiral. It's a chiral environment that interacts differently with the enantiomers.